The Center for the Improvement of Human Functioning International presents this luncheon lecture. Today's topic, how vitamin C fights cancer. Your presenter, Ron Honeyhockey, MD.
Thank you. Well, I'm very grateful to see such a good crowd here today. I think this is a very important topic. I don't know about you, but as I get older, I have this sense that it seems like everyone's getting cancer. Does anyone share that with me? You know, that you hear about this person, that person. It seems to be a growing problem. I know it does relate to the aging process. But to me, an even more important issue is the fact that a lot of people are still somewhat fatalistic about cancer and look upon it as, if not a death sentence, a very difficult time ahead with the types of therapies that we have available in conventional medicine. But here at the center, for the last 15 years, we have been pioneering a new understanding that can help those patients who do get cancer more effectively treat the cancer and reduce the side effects of the treatments that they undergo, and hopefully use this information to prevent cancer. But I'm going to emphasize today that I'm speaking about a new understanding. Now, many of you here may have not have heard any of the previous lectures that we've done on vitamin C, and so this lecture today will kind of pull in a lot of that information, but not all of it. And so for more details, we do have a series of talks that I've given and other researchers here have given on how to monitor IV vitamin C, what really causes cancer. But today I would like to emphasize the mechanism of how vitamin C can help either you, your family member, or a friend fight cancer. And more importantly, I'm hoping this information makes it out to the medical profession at large, because there are some misunderstandings about vitamin C and how it fights cancer that we're hoping to overcome with better information. And so today I'm shooting for clarity. I always want my lectures to be clear, but probably more so than ever before, I hope that this group gets a good understanding, a good clear understanding of how vitamin C can be a very effective tool in the fight against cancer. And so here at the center, the Bright Spot for Health, this has been one of our major research focus areas. We have a lot of patients coming to us these days with vitamin C, or with cancer, to be treated with the IV vitamin C. And to get started, I would like to dedicate my lecture today to the first successfully treated cancer patient here at the center. George Williamson developed in 1980 adenocarcinoma of the right kidney. His case was written up by Dr. Jackson, who's here today, and published in the Journal of Orthomolecular Medicine, which you can now read online. And George had his, appropriately had his kidney removed, but by that point he already had metastases that had already spread to his lung and his liver. And I'm sure most of you know that once it starts to spread, that's a very ominous progression of the disease. But based upon Dr. Reardon's relationship with Linus Pauling, Dr. Linus Pauling, two-time Nobel Prize winner, who was very interested in vitamin C, and Dr. Ewan Cameron, a Scottish surgeon who was doing IVC research in Scotland, Dr. Reardon started George on 30 grams of IV intravenous vitamin C twice a week, and George began to feel better. And by the time he had completed 15 months of this therapy, he went back to his oncologist. The oncologist verified that the metastases were gone, the cancer had cleared up, and then 14 years later, at the age of 84, George died of something completely different than his cancer. And just earlier this year, his wife, Opal, passed away, and I've been very grateful to both of them, their enthusiasm for the center. And I always want to remember that we're here at the center to serve people. Cancer isn't something that just happens out there. It happens to real people, to people like yourselves, our family members. My wife has had breast cancer. We know we have friends who fall victim to the cancer. So we need really good tools to help patients overcome this rather dreaded illness. Now, I'm going to be talking a little bit of chemistry today, but remember, my goal is to make it understandable. So for all of you that used to freeze up in school whenever the word chemistry was mentioned, you can relax. I just want to define some very simple terms here. You need to understand this if you want to understand what makes vitamin C, ascorbic acid, so special in the realm of cancer therapy. Well, there's a term called redox, and it's really part of the whole life process. But I'm sure you've heard the word antioxidant. An antioxidant is something like if you cut an apple and you leave it exposed to the oxygen will oxidize the surface of the apple and it will start to turn brown. And so, but if you squeeze a little bit of lemon juice on it, that's a reducing agent. It's an antioxidant. So an antioxidant reduces the oxidative effect. And so sounds a little confusing, but as we go along here, I want you to see that this actually is kind of a circular thing, in that you can oxidize, but you can also reduce, and you can regenerate some of these molecules like vitamin C to make it kind of put it back into the battle again and recharge it and give it new life so that it can do its job better than it otherwise could. There's a very interesting phenomenon that occurs around vitamin C, and I'm going to try to explain this. You know, most of us have heard the term vitamin C. Vitamin C is also ascorbic acid. Ascorbic acid is the chemical term, but we refer to it as vitamin C because vitamins are small amounts of something that does something else, and we know that vitamin C prevents what disease? Scurvy, right. But it only takes a very small amount, and so the recommended daily allowance to prevent scurvy is like somewhere between 60 to 90 to maybe a little bit more of milligrams of vitamin C, about the amount of vitamin C that would fit on the head of a pin. Now, do you think that amount would be enough to treat cancer? No, we have to think of vitamin C in terms of dosage, and so if we're going to get into using vitamin C. Now, maybe small amounts of vitamin C could be somewhat helpful in preventing cancer, but in treating cancer, we're going to have to use larger doses. So at low doses, vitamin C acts almost purely as an antioxidant, which most of us know it as. It's an antioxidant. But what's surprising, and which most oncologists still don't know or understand, is that at much higher doses, vitamin C can act as both an antioxidant and a pro-oxidant. Now, it doesn't suddenly change. It always is and always has been and always will be an antioxidant. But it enters into a special chemical reaction in the body that creates a pro-oxidant effect, which we're going to go into in just a second. So here we have vitamin C acting as an antioxidant. And basically what antioxidants do is they have these, here's ascorbic acid, vitamin C. It's got these electrons, and it very generously donates them to this treacherous free radical, which can act as a harmful oxidant to your body. We think it's oxidants and excessive oxidants over time that injure the cells and set the cells up, change the DNA, set them up for the formation of cancer. So vitamin C, ascorbic acid, can neutralize free radicals. But when it does, once it's given its electrons away, it now becomes dehydroascorbate. This is the reduced form, this is the oxidized form of vitamin C, and the body gets rid of it. So here's a specific example where an iron atom, two iron atoms, are reduced. The +3 is reduced to the +2 by ascorbic acid, and now you have reduced iron, and the dehydroascorbic acid is just excreted in the kidneys. We're not using it anymore. But what happens to this reduced iron? Well, it can interact with oxygen. What happens when you take a piece of metal, iron, lying out on the ground in the air? Doesn't it rust? Rusting is a form of oxidation. So It rusts and because it interacts with oxygen, and it forms an oxygen-free radical, which is very damaging, and that results in the formation of something that we all are familiar with, which is hydrogen peroxide. Hydrogen peroxide. And we know that hydrogen peroxide can be used to treat wounds. If you know a little bit about cell biology, it has a regulatory effect in the cell. It can be used to fight infections. So this is how, when you put vitamin C in and it interacts with iron, it can have a pro-oxidant effect in the body. Let's take this one step further. The peroxide itself can interact with more reduced iron, if it's available, and it will form a very, very harsh free radical called the hydroxyl radical. And this hydroxyl radical is much more potent as an oxidizing agent than even hydrogen peroxide itself is. Now here's the key part. This is the part that most doctors don't understand, and so you're going to be ahead of most of the oncologists in the world just by understanding this one slide. Namely that if you're using vitamin C in bigger doses and you're reducing the iron in your body or the copper, any kind of metal in your body, if you reduce it, then that can go over and interact with the peroxide and form the hydroxyl radical. But if you can take this oxidized iron and once again reduce it, do you see how this is starting to form a cycle? What you need, though, is you need a continuous supply of high-dose vitamin C. This is the IV vitamin C. If we're putting IV vitamin C in large amounts and we're reducing the iron and it's interacting with the peroxide, what we have happening is like a water wheel. And as long as the vitamin C, the ascorbic acid, is going in and the oxidized form is going out, it's turning the wheel and producing more and more of the hydroxyl radical. It's the hydroxyl radical that's acting as the pro-oxidant to kill tumor cells if you have the right dosage. If you have the right dosage. And this has been the rub. This is why so many doctors and so many researchers have misunderstood vitamin C. They think of it as a little trace vitamin. But in order to get this pro-oxidant effect, you're going to have to add in large amounts of vitamin C in order to reach a certain threshold to where the hydroxyl radical is formed. Now, this is not just me talking. This phenomenon was recently verified at the National Institutes of Health in this particular research project. Ascorbate in pharmacologic concentrations, not nutritional, but pharmacologic concentrations, selectively generates the ascorbate radical and hydrogen peroxide in extracellular fluid in vivo. In other words, in a living body, this phenomenon happens. And so you can read about it in the Proceedings of the National Academy of Science. Now, coming back to what role does oxidants play in the body? And so we were talking about the word redox, cellular redox environment. A simple rule of thumb is that the environment of healthy cells is reducing. In other words, the free radicals are controlled rather than oxidizing. We depend upon oxidation for metabolism, immune defense, and cell signaling purposes, but we must avoid the damage it can cause. In other words, when your oxidation gets out of control, there's too much injury, too much damage to the apple surface, it becomes rotten. Too much damage to the iron, you can't use it anymore because it rusts too much. Well, see, the body life is a process of keeping that in balance, keeping it in check. And that's why we now know, it's a clearly established fact, that colorful fruits and vegetables, which are rich in antioxidants, create, just what I just said, a healthy reducing environment in our cells. And that helps us prevent the cellular damage that can lead to cancer. So vitamin C as an antioxidant is a great preventive agent. All of your antioxidants help to control excess oxidation. But what we need, if the damage is already done and the cancer has emerged, you can't rely upon just the antioxidant properties of vitamin C. Now we need something a little bit tougher, a little bit more potent. That's where the high doses of vitamin C has been shown to kill tumor cells, and that's what we call tumor cytotoxicity. It's toxic to the cells that make up tumors. So the high-dose intravenous vitamin C generates hydroxyl radicals which can damage, it would damage all cells, except that healthy cells have a protection built in. Since peroxide is kind of a normal part of cellular physiology, healthy cells have their own protective enzyme called catalase. What do you think cancer cells have? Do you think they have catalase? No. They're low in catalase. And that's what makes IV vitamin C so slick. That's probably not the right scientific word. But the fact that it can at the same time act as an antioxidant and protect your healthy cells and yet generate the hydroxyl radical, a very powerful radical that attacks the cells that are low in catalase, namely your cancer cells, that means this is almost like a smart bomb or a smart drug in the sense that it's going to strengthen your basic protective mechanisms but attack the invading tumor cells. And that's why we're so excited about IV vitamin C here at the center. It's not just us, though. There's been a number of researchers who have demonstrated this phenomenon. We're not the only ones anymore that are looking into this. I think Dr. Jackson, I had him do a search on IV vitamin C studies around the world, and there are over 60, I think, that are now going on. So this is now, the research is starting to get behind this. But I still think the general understanding of vitamin C is that it's just a little vitamin. You drink it in your orange juice. Yes, it's good to help you prevent cancer, but when you've got a really serious disease like cancer, vitamin C is not strong enough. Well, folks, I think it is strong enough if you use the right dose. So this chart, what it shows here is it shows us how oxidation works. Normally, when you increase the level of oxidative stress in any cellular environment, if you injure the cells, they will start to divide more rapidly. It's like an inflammatory response as they try to adapt to that particular stress. But if the damage is great enough, there are genes, the P51 gene, which will tell the cell, hey, it's time to quit. There's too much damage here, and it will create a kind of automatic suicide of the cell, what they call programmed cell death, apoptosis. And so this is normally what happens, and this is what chemotherapy and radiation therapy takes advantage of. When you've got cancer, we're pouring on, the oncologist is pouring on the oxidative stress, hopefully in a focused way, to get your tumor cells to die, to get that tumor to shrink. The problem is this high level of oxidative stress can be harmful to normal tissues. But this is basically the mechanism of how chemotherapy and radiation therapy works. The Reardon IVC protocol, in a sense, is using the same mechanism, oxidative stress, in the form of the hydroxyl radical, but at the same time we're protecting the healthy cells. Now we don't advise this as a standalone therapy. We think it's best used in conjunction with whatever type of conventional treatment you're getting. In other words, if the oncologist says you ought to have radiation therapy and maybe some chemotherapy, do this in conjunction with that therapy. Now, this is where the misunderstanding gets in the way, because a lot of oncologists still think of IVC as only an antioxidant, and if you're taking a chemotherapeutic agent which causes oxidative stress in order to kill the tumor cells, a lot of the doctors are afraid that the vitamin C is going to neutralize the effects of the chemotherapy. Our research tells us differently. Even theoretically, we would say that at the same time that the vitamin C is protecting the healthy cells, it's going to help the chemotherapy attack the cancer cells. So this is all written up in a protocol that we have available to practitioners at this time. We have been doing a lot of IV vitamin Cs. We have a lot of experience. Since 1994, the number of vitamin C, IV vitamin Cs done on site has continued to grow. And basically what happens as we increase the dose of IV vitamin C, we usually start people out at 15 grams, we go up to 25, keep taking their dose up, and then after we infuse the vitamin C, we take and do a measurement of their blood on the other side to see how much vitamin C have we gotten that concentration up to. And just to kind of give this, I didn't put it in here as a line, but if we were to take the vitamin C levels of everyone in the room here, assuming that no one had had an IV vitamin C, it'd be around 1 or 1.5. And what we're shooting for with cancer patients is somewhere around 350 to 400. So it's like 400 times the normal blood level of vitamin C that's required in order to really generate a good, strong dose of hydroxyl radical to attack those tumor cells. And so we use the post-IVC level as a way of confirming that the dose that we're giving is right for that particular patient, because each patient's different. They have different diets, different diseases, different oxidative stress loads, different levels of cancer. Even the same type of cancer can be at different stages in different people. So we use that to help us guide our therapy to make sure that we're getting an adequate amount of dosage. And we've been studying this pretty carefully. Dr. Jackson has kept a real close eye on the lab. And you can see that as we increase levels, we get a higher range. Now, some people, even at 60 grams, have a very low level because they've got a huge amount of oxidative stress. So in that case, if the tumor's still there, they need to get it out. They need to change therapies. They need to do something so that we can reduce their oxidative stress load and get their vitamin C level up as high as possible. This is some more of the groundbreaking research that was done here at the center in the 90s, where we took different lines of cancer cells and then we grew them on culture plates with different concentrations of ascorbate, vitamin C. And as you can see, as the concentration of ascorbate in the growth media increased, it killed, the percent surviving cells went down, 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 and around 350 to 400, almost all the various cell types of cancer were killed by this dose of vitamin C. Now, I do want to show you another study that we did here that I think is important, and this is the reason why I tell patients you don't want to rely upon IV vitamin C alone if you have cancer. When we took and we grew cancer cells, this was colon cancer cells, on a thin layer culture plate, it didn't take very much vitamin C to kill off all of those cancer cells, 200 milligrams per deciliter. However, if we grew that same type of cancer cell on a dense layer, a real thick layer, it took quite a bit more vitamin C to penetrate in to actually kill those tumor cells. It did kill them, but it took quite a bit more. And then Dr. Kasari from the National Institute of Health, who's one of our consultants, he had a model that simulated a tumor. It's called the dense hollow fiber model. And it's like a tumor growing in your body. And you can see the green line, we never did completely eradicate those cells because the vitamin C had to try to penetrate in to the tumor. So what I tell patients is get the tumor out if you can. Remove the tumor if it's possible. Have the radiation therapy to shrink it down. Do the chemotherapy to shrink the tumor down as much as you possibly can. That's going to get you into the realm where the IV vitamin C is going to work more effectively. And if you use the IV vitamin C simultaneously, you won't have the side effects that a lot of people have with the various forms of chemotherapy. Now, this research that I just showed you, this was replicated. It was done in the 90s, but again, it was replicated at the National Institutes of Health and published in 2005. Pharmacologic ascorbic acid concentrations selectively kill cancer cells. Action as a prodrug to deliver hydrogen peroxide to the tissue. So now we've got a validation of what we've been doing, and we just need to pick up the action here and find out, okay, how can we do what we do even better? So in summary here, IV ascorbate reaches cytotoxic plasma levels for only a short duration. And I'm going to, this is the second part of the lecture now. Because I think, does everyone have a pretty good idea now how IV vitamin C works and it kills cancer cells? But we give it usually about twice a week. Sometimes we give it 3 times a week. But those plasma levels that we achieve with an IV are only high for several hours, relatively short duration. We do it typically about twice a week. my concern is the potential exists for the emergence of IV redox chemotherapy, which is the way they now refer to it at KU Med Center, IV redox chemotherapy. What about resistance tumor cells starting to reemerge in between IVCs? And can we improve the effect of the IV redox with oral vitamin C redox and something that I'm going to call redox recycling? So now I'm going to enter into a little bit different discussion with you, because for a while we were kind of forgetting about the value of oral vitamin C. There's no question that IV vitamin C, if you have cancer, you want to do IV vitamin C, but can we improve the results of IV vitamin C by using the appropriate dosages of oral vitamin C in conjunction with other specialized nutrients? So now let's talk a little bit about redox recycling. Remember, I told you the dehydroascorbate, which is the oxidized form of vitamin C, is excreted rapidly by the kidneys, whereas the ascorbic acid is generally reabsorbed depending upon what blood level you've got. And so what we think, though, what we might be able to do before the dehydroascorbate is jettisoned, what if we reduced it back to vitamin C? What if we put it back into action again and preserved that vitamin C so that it could be utilized again? And this term is called redox synergy. It's the technique of using several antioxidants in a synergistic manner to increase the efficiency of redox recycling. Okay? Just to put this in graphic term, here's your dehydroascorbate, the oxidized form, and if you use antioxidants, and there's a number of antioxidants that you can use, and donate those electrons to the dehydroascorbate, now you've got ascorbic acid back again. It's ready to go. And putting this into my water wheel analogy, here's the ascorbic acid coming in, here's the dehydroascorbic acid being formed. But, you know, if we don't get enough of this, we're going to run out, and we may not make enough of the hydrogen peroxide and the hydroxyl radical that we need. But what if we could somehow recycle the dehydroascorbate back up here and put it back through the loop again one more time? And this is what synergistic antioxidants will do. If you're using vitamin E, selenium, D3, zinc, and other forms of antioxidants, you can regenerate ascorbic acid from your dehydroascorbate and thereby raise your level of the hydroxyl radical in your bloodstream using oral forms of vitamin C. At least this is the hypothesis, that redox synergy can do this. Okay, that's just what I just said. Well, there was a study done last year. It was a small study where we looked at whether or not in healthy volunteers a mixture of oral antioxidants versus just vitamin C or E by itself would increase the antioxidant capacity of their bloodstream. This was measured by looking at the percent inhibition of induced lipid peroxidation. Now that's a mouthful, but all it really means is if you've got free radicals wandering around in your bloodstream, it can damage your cell membranes. And your cell membranes are made out of lipids. And if you get lipid peroxidation, that's damaged cell membranes. Well, so they looked at 4 different groups in this study. People who were taking just vitamin E alone, 400 units. There was another group that was taking vitamin C alone, 500 milligrams. Third group was taking C plus E. And then the fourth group was getting this mixture of antioxidants, which you can see on your sheet there: selenium, zinc, folate, B vitamins. And what they found is that indeed redox synergy did occur, that the mixture of vitamins and minerals was more efficient than vitamin C or E alone. They presumed because this antioxidant mixture contained various antioxidant compounds with different redox potential, leading to the possible development of chain reactions. So you can use antioxidants in combination with vitamin C to stop the damaging effects of free radicals. Now, how does this apply to cancer? Well, we're not the only ones that have been trying to look into this whole question of what do we do about cancer. There was a good friend of Dr. Reardon's Dr. Abram Hoffer, who for the last 50-some years has been a leader in the field of orthomolecular treatments of various diseases. And so he developed a cancer regimen back in, well, even before 1978, but he put it to the test in a 15-year study where he looked at 134 advanced cancer patients, and he offered them this combination: beta-carotene 30,000, B-complex 50 to 100, 12,000 milligrams of vitamin C, and nowadays he's taking them up as high as 40,000. This is oral vitamin C, 300 units of E, 600 of selenium, and 60 of zinc. When you have a serious illness like cancer, your digestive system can handle a lot more vitamin C than what it can if you're just in an everyday normal state of health. And so he offered this to 134 patients, and there was some of them they entered the study, but they didn't want to do the vitamins, and some did. And so what he found, the people who took his regimen, these are the various different types of cancer: breast, uterine, ovary, lung, pancreas, and then all types. He found that the number of months survival was much higher with the people that took the vitamins compared to the number of months that people didn't. So people that took the vitamins had about 45 months of survival compared to 2.6 months. This is also published in the Journal of Orthomolecular Medicine, totally ignored by conventional medicine. But to me, it's an important finding because it indicates that maybe redox synergy and high doses of oral vitamin C does have a role to play in enhancing the effectiveness of IVC therapy. So now we look back at another study, one of the groundbreaking studies in this whole field of using vitamin C in cancer patients. This was Dr. Cameron and Pauling's study where they gave terminal cancer patients 10 grams of IV vitamin C daily for 10 days, and then they gave them 10 grams orally to follow. And they were able to show a fourfold increase in life expectancy. Now what we don't know, and the reason I'm going to point this out, is that we don't know if they got it once a day or several times a day. 10 grams a day, you can try to take it all at once, or you can split it up and take it during, several times during the day. Now they thought in their paper, and they said if they would have used higher doses than 10 grams, they might have even had better results. And I'm going to show you that maybe they indeed would have. Now, unfortunately, when this was published back in the 70s, Mayo Clinic said, okay, we're going to try to replicate this study. But when you do a replication, you should at least do the study the same way that the original researchers did it. Well, the Mayo studies did not involve any IV vitamin C. It was all just oral vitamin C given once a day. And so they gave 10 grams of oral vitamin C to 200 late-stage cancer patients. There was a lot of questions raised about how well the study was controlled, but they did not show any statistical benefit. This is one of the reasons why conventional medicine said, hey, let's just forget the whole vitamin C issue because this is the definitive study. Well, it really wasn't, but that's kind of what happened back then. Now here we are bringing up the whole vitamin C thing again because we're getting new research findings to suggest that maybe this could be a useful tool in the fight against cancer. Dr. Reardon himself was one of the authors of this study on vitamin C pharmacokinetics. It was sponsored by the National Institute of Health, and what they did is they looked at what happened when you gave vitamin C orally compared to IV, starting with a very low dose. And they took the subjects and they completely depleted their vitamin C. So they were starting with subjects who were really in a state of scurvy. And then they looked to see what happened to their blood levels when they started giving them very small amounts. And the most they got them up to was 1.25 grams of vitamin C. And that was what they utilized then to make their calculations. They calculated then what would happen if they gave them up to as high as 100 grams of vitamin C. And the highest level they were able to get after 1.25 grams of vitamin C was a blood level of 2.4, which was, it's not a very, our normal range here at the centers is 0.6 to 2.0. So it boosted their level a little bit, but not very much. Whereas when they gave that same amount IV, it boosted their blood level up to 15.6. Now this is a significantly higher level, and this led them to in the conclusion of their study, they said, you know, we need to think of vitamin C when it's given IV as being something different than when it's given oral. And for this reason, we should reopen the study of vitamin C, looking at it as an IV therapy for cancer as opposed to an oral therapy. And this was just some of their graphics, just to kind of show you this was, you know, vitamin C, it was much higher. The blood levels that you were able to get much higher, whereas with oral vitamin C, you could only get up to about, the maximum they were able to get up to was 3.9. So, the implications of this study is that intravenous vitamin C is a plausible means of delivering enough vitamin C, ascorbic acid, to generate the hydroxyl radical. Now, the average plasma vitamin C level is about 1.2, and unfortunately what this report stated was that you really don't need to take more than 200 milligrams per day, because if you do, it's all going to be lost in the urine. How many of you have been to your doctor and told him that you were taking vitamin C, and he says, oh, all that's doing is giving you expensive urine, right? You probably heard that. Well, a lot of that statement is based upon this and other studies that 200 milligrams per day is a saturation dose. Therefore, let's not even pay any attention to oral vitamin C. If we're going to use it, it has to be given just IV. Okay? Now, don't get me wrong. If I have cancer, I want IV vitamin C as the treatment of choice. But what I'm talking to you about now is that maybe we should consider using oral vitamin C in between in order to keep the levels of vitamin C high enough to possibly generate the hydroxyl radical. So their computer calculated that the highest level you could possibly get was 3.9, which I'm just going to call the max C. In other words, based upon their model, if we all took as much vitamin C as our digestive systems could possibly handle, the highest we could get would be 3.9. And I'm sure all of you are thinking, well, gosh, the treatment for cancer, in order to be effective, has to be around 350 to 400. It has to be 100 times this amount. So this would make it seem like oral vitamin C doesn't make any sense at all. But here's the deal. The role of science is to make predictions, and so their model predicts 3.9. If we can show that if science says that all geese are white, it only takes one black goose to prove the postulate wrong. So let's see if we can find some black geese here. And so I'm going to show you two unpublished studies, one done by Steve Hickey and another one done by myself. The first one is the pharmacokinetics of oral vitamin C, and what Hickey wanted to do is he wanted to see if he could prove that using oral vitamin C he could break the barrier. In other words, break the sound barrier for vitamin C. And indeed, even with just a 5-gram dose of standard vitamin C and then a 5-gram dose of something called liposomal vitamin C, he was able, at about 3 hours out, to exceed that 3.9. This is the NIH study showing that this is about as high as you can go. So he did it with 5 grams, and then if you look at this may be more than you want to know, but vitamin C pharmacokinetics follows it has a dual phase to it. In other words, if you're less than 1.2 in your bloodstream, nature protects us from scurvy by reabsorbing the ascorbic acid in our kidneys. It'll work very hard. That's why even if we're not getting any vitamin C, we won't develop scurvy right away, because the kidneys will keep reabsorbing the vitamin C as long as it can. It does not reabsorb the dehydroascorbate. But once you get up into the phase 2 level, 1.2 to 3.9, then the kidneys just excrete the vitamin C about as fast as they can, which is a half-life of 30 minutes. So whatever your blood level is, half an hour later, it's going to be half, because the vitamin C is excreted so rapidly. And so once again, putting Dr. Hickey's numbers in this chart, this is phase 2, this is phase 1, he was able, with just a single dose of vitamin C, to exceed the 3.9 barrier. And then when he did a 20-gram dose, he was able to exceed it by even more, which makes sense. And then when he did a 36-gram dose, which gave him a really bad case of diarrhea, he was able to really break the barrier in 2 subjects. He almost doubled the plasma level of vitamin C. And so he shared this study with me, and it made me think, well, gosh, maybe we can use oral vitamin C as supportive therapy to IV vitamin C and thereby get an even better result with the cancer patients that we're caring for. And so I thought I would like to try this with myself. And so I did a little N of 1 study looking at what Hickey calls dynamic flow. You know, the NIH computer says that the plasma is going to be saturated after just 200 milligrams of vitamin C, but that is only a single dose. What if every 3 hours you took 200 milligrams? Which means that in the course of a day long of taking vitamin C several times a day, you're going to build up your vitamin C level. Okay? So this should be able to, using this technique, we should be able to break this 3.9 barrier without necessarily going to really high dosages at any one time. So the reason why we think this is possible is that one of the pioneers in vitamin C, Irwin Stone, sent a letter to the discoverer of vitamin C, Albert St. Georgi, that Irwin Stone had a friend named Joe Keininger who had prostate cancer. And Joe didn't want to take chemotherapy, and so he started increasing his oral vitamin C very slowly over the course of months and months. And he got his daily intake of vitamin C up to 80,000 milligrams a day without diarrhea. And he was at that level for 2.5 years. He was able to achieve a blood level of 32 milligrams per deciliter. Now remember, the NIH model says the highest you can go is 3.9. So what he showed here is that maybe the model is not correct. And Hickey's data shows that maybe the model is not correct. And so here's my data from the N of 1 study that I did, where I started out, I normally take about 10 grams of vitamin C a day. And what I did is each day I would take vitamin C at 7 o'clock, 10 o'clock, 1 o'clock, 4 o'clock, 7 o'clock, and 10 o'clock. So every 3 hours I was taking a dose of vitamin C. And the first day was 1 gram, so that would be an additional 6 grams. There's 16 grams. The second day was 2 grams every 3 hours, 3 grams every 3 hours. And I finally got it up to 4 grams every 3 hours, plus the 10 grams that I normally take, for a grand total of 34 grams a day. And I had to have my secretaries helping me to keep track of all this, so I'm not sure. We have to work on how practical this is for patients. But part of what this is just to show you that if you take vitamin C frequently throughout the day, you should be able to generate some fairly high levels of vitamin C. And you can kind of see over here, these at 8 a.m., 11 a.m., 2 p.m., 5 p.m., I had my blood levels checked. So in the course of this experiment, I had 51 blood draws, and my arms looked like I was a drug addict. But other than that, we were able to get some really good data about the ability to raise vitamin C levels. Now, normally, in most laboratories, like for example here at the BioCenter lab, the highest recorded plasma C level we've ever had was 5.6. And using the strategy that I used here, I was able to achieve a level of 5.5. So, and then at most labs, the highest level is 3.9. So this method may be a way of using antioxidants and vitamin C in order to raise a person's plasma level. So this is a summary of the average of the vitamin C levels for each day. Here's 10 grams, 16 grams, 22, 28, 34, and then I kept the 34 going, and you can see that each day the blood level was going higher and higher. If I was able to sustain this for 2.5 years, like that one prostate cancer patient, you can extrapolate that maybe the blood level would have just gotten higher. Okay, so this to me shows, and this got it up to 4.3, so I clearly exceeded the 3.9 max just by using oral vitamin C. So this is redox cycling. Now, what about the ability to generate the hydroxyl radical? Well, we know that you can use alpha lipoic acid and vitamin K to do this. And so we have a special supplement called IVC Max, which has vitamin K, lipoic acid, selenium, and a number of antioxidants, which we have found to enhance the effects of IV vitamin C. And so now with lipoic acid, you can see that the redox cycling phenomenon that we were doing with just vitamin C alone can be achieved with lipoic acid as well. And actually, this research was done here at the center showing that by adding lipoic acid to vitamin C, you reduce the amount of vitamin C that you need in order to kill tumor cells. The other one that does this is vitamin K. Vitamin K will also redox cycle and generate the hydroxyl radical. Now, what I did in my little research study was add the IVC Max to the 34 grams of vitamin C that I was taking per day. I really did not know what was going to happen. I thought maybe the antioxidants would take my levels even higher. But what actually happened when I added, I got up to 12 IVC Max capsules a day in addition to the other things that I was taking. And interestingly enough, the blood levels of my vitamin C started to go down. And the only explanation I can come up with at this point is that I was starting to create the hydroxyl radical, which was neutralizing the vitamin C. And so my average vitamin C levels started to go down once I added the IVC Max, which to me, at first I was somewhat disappointed, but then I realized this must be the oxidative stress that we shoot for with IV vitamin C, achieved with using an oral program. So this is also, the reason why this can be important is that if you look at the research that's already been done, you can achieve apoptosis with vitamin C in just a couple hours. NIH data showed that there was 30% death of the Burkitt's lymphoma cells with an ascorbic acid level of only 5.3 milligrams per deciliter with an exposure of only 1 hour. Well, I want to show you my data here. I had two readings where my blood level was over 5.3. Here's 5.3 and here's a 5.5, just using oral vitamin C. So had I had a lymphoma, just using the oral vitamin C for that short period of time, that would have been creating a selective toxicity to that type of tumor cell. So this kind of looks at the whole study, how it went up, and then when I started adding the IVC Max, it started to go back down. So this to me is oral, at least some evidence of oral C redox-induced apoptosis. What we're doing here is enhancing IVC redox by maintaining low-grade oxidative pressure between IVC infusions, and hopefully that will reduce the likelihood of developing IVC resistance. There are some patients that are doing very well with IV vitamin C, and then suddenly the tumor starts to grow again. And we're hoping that it'll reduce the risk of cancer recurrence, enhance survivability and quality of life, and possibly lower cost and lower toxicity. So this, if you can think of IV vitamin C as an adjunct to chemotherapy and radiation, oral vitamin C is an adjunct to IV vitamin C. So my concluding points are that high-dose IV vitamin C has been demonstrated to generate tumor cytotoxic doses of the hydroxyl radical through redox cycling. And twice-a-week IV vitamin C creates short bursts of this cytotoxicity. And it makes it a very good adjunct therapy to standard chemotherapy and radiation. But what about using oral vitamin C in high dosages in order to make the IVC work even better? So the frequency and level of dosing of oral vitamin C is a critical component of any redox synergy strategy. So the next phase of our research is what level of oral vitamin C do cancer patients need to have in order to achieve this results. We do know that if you add lipoic acid, vitamin K, and copper, you can possibly induce this hydroxyl radical formation using just oral strategies along with the IV strategy. So again, our goal here at the center is not just to treat cancer, but to take care of cancer patients. Our goal is to give you a level of hope that goes beyond just conventional treatment. It's conventional treatment plus using innovative nutritional strategies that will protect your white blood cells, protect your immune system, protect your health while you're fighting the cancer, and at the same time improve your overall quality of life. And so this lecture would not be possible today without the insight and vision and efforts of Dr. Hugh Reardon. So anyway, this is our contribution thus far, and I want to just fill you in with where we've come to this stage. And so if there's any questions, I'd be happy to try to answer them at this point.
I was diagnosed with lymphoma last August, and I have been through a regimen of chemotherapy. And the first time I saw the oncologist, I believe it was the first time, I asked him about the vitamin C IV drips, and he said it wouldn't help this type of cancer.
Yeah, as I mentioned earlier, there is a misunderstanding among oncologists that IV vitamin C as an antioxidant would interfere with chemotherapy and radiation. And then the other part of their incomplete understanding is that vitamin C is not strong enough to attack the tumor. And so what I tried to demonstrate here is that if you use the right dose, you can achieve the formation of a substance, the hydroxyl radical, which is very effective at attacking the tumor. The second part of the lecture is using oral forms to make the IV work even better. So that's kind of the innovative part of the lecture. But the part that we stand on that's pretty solid is that the IV would be helpful and would not interfere. So, but that's not the view of most oncologists yet. And so that's why I'm grateful for all of you being here to understand what we're doing and how this information needs to get out to the average doctor and oncologist. We do have an oncologist on staff now who, through careful review of our research, has joined us. Each month he's here part-time to work with cancer patients and is strongly behind the IVC therapy for all the various types of cancer. Yes, sir.
If you don't want to take the 200 milligram of vitamin C daily or every 2 hours, how much fruit and vegetable you have to have?
Well, I think the research is very clear. Even people who have cancer should be eating more fruits and vegetables because those colorful phytonutrients are very beneficial in your body's defense against the cancer. So I think as much as you can and still be comfortable, eat your fruits and vegetables before and even after the diagnosis of cancer.
I have a friend who has been diagnosed with lung cancer. He lives in Kansas City. Can he get this treatment there, or is it only available?
No, it's available around the country now. There are a number of sites, and Kansas City also has a site where IV vitamin C therapy is available.
Where is this?
KU Med Center.
KU Med.
Dr. Ron, I certainly appreciate your chemistry background along with your medical background, and I appreciate the emphasis on the oral vitamin C. And I was wondering, during your study, do you have a recommendation on which oral vitamin C was more readily absorbed or peaked the values faster, or can you highlight?
Well, what I used in this particular study was a new form that's really very hard to get a hold of. It's really more at the research stages that did not cause diarrhea. Now, we do have a powdered form of vitamin C called Beyond C, which we have found is very well tolerated. It's very easy to take. People can take it 2 or 3 times a day in juice and have no trouble with it at all. So right now, that's our #1 preferred form for cancer patients.
In a powder?
It's in a powder, so you don't have to be taking lots of capsules.
Can you sell that here?
Yes. Okay.
How much the aspirin affect the benefit of vitamin C?
I really don't think, it depends on how much you're taking. If you're taking like a 81 milligram aspirin, it's certainly not going to affect it at all. Whereas if you're taking a lot of aspirin for rheumatoid arthritis or something, there may be somewhat of a reduction in the effectiveness, but not very much.
Or it could be for clotting. Some people, they take aspirin for clotting.
Right, and that's where I think you can just stay right taking that and there would be no interference. So, okay.
Does it affect the kidney or develop kidney stones?
Right. You know, that, again, that's another misunderstanding. I've often told people that given the fact, like Dr. Reardon himself, before he passed away, he estimated that he had ordered 78,000 IV vitamin C's during his lifetime. And so, and you saw the numbers that we typically do here each year. If vitamin C in high dosages really did cause kidney stones, we would be the kidney stone capital of the world. But as it is, I've been here 21 years, and I can only think of one patient that the next day developed a kidney stone after all the vitamin C infusions that I've witnessed. So I think that's a misunderstanding that it causes kidney stones, but that idea is still in many doctors' minds, but it's really not a reality in truth.
Okay, some great questions.
Well, thank you very much, everyone, for your attention, and hopefully this will be of help to you.
The preceding program was presented by the Center for the Improvement of Human Functioning International in the Bright Spot for Health Lunch and Lecture Series. To inquire about additional health-related information available on DVD, audio CD, VHS, or audio cassette, simply call 316-682-3100 or drop by 3100 North Hillside in Wichita, Kansas. To discover more about the center and what we have to offer, be sure and visit us on the web at www.brightspot.org.